Our cities are built from reinforced concrete and steel. But what happens after a blast caused by terrorist attack or accidental explosion? Buildings remain damaged. They can collapse. But what if we could not only protect our buildings, but help them recover? Can we achieve this with a strengthening layer thinner than your finger? My research BLASTEX is about making that possible. During a blast, concrete cracks. The reinforcing steel deforms. There's a risk of flying debris, risk of collapse. This is what we civil engineers call permanent damage. It is like bending a paperclip. You can bend it once, maybe twice, but it will never return to its original state. To solve this problem with permanent damage, I propose to use textile reinforced concrete, or in short, TRC. TRC is a composite of fine cement material with textile reinforcement. Now you might think textile in concrete sounds a little bit funny, but the textile here, it's not fabric. It is a high-performance carbon grid. And because carbon does not corrode, the reinforcing layer can be thin as your finger. We apply this strengthening layer on the surface of existing structure. Think of it as a protective skin. And those carbon fibers, they are 6 times stronger than steel at a fraction of weight. But the strength here is not the key, because unlike steel, carbon is elastic, like a spring. That means that under load, it stretches, and when the load is removed, it returns to its original position. And this is exactly the key idea behind BLASTEX. During the blast, the textile reinforcing layer stores energy like a spring, and when the blast wave passes, the spring pulls back the concrete structure together. There's no flying debris, no risk of collapse. And this is what we civil engineers call self-centering. And exactly this is the main idea behind my project. Self-centering under blast loading by using textile reinforced concrete. Less like a paperclip, more like a spring. At Virginia Tech, I study reinforced concrete beams strengthened with textile reinforced concrete in a shock tube. Shock tube is a laboratory device that helps us to create controllable and repeatable blasts. My key question is simple. Can the textile reinforced concrete strengthening layer actually help this beam to recover? Let me show you. On the left side, you can see a conventional beam under the blast loading. Let's see what happens. The beam is damaged beyond repair. Now, on the right side, the same beam, the same blast, but this time with a thin strengthening layer. Let's see if that helped. Now let me ask you a question. Would you feel safer under the first beam or the second one? And while experiments are important, I need to know what's happening inside of the concrete in a fraction of milliseconds. For this reason, I built detailed computer simulations to help me run hundreds of different loading scenarios and come up with smart structural design. So my message today is simple. By using smart structural design and high-performance materials, we can move from structural collapse to rapid recovery. I have shown you today that a layer thinner than your finger can save your life. My research BLASTEX is about building safer, resilient, self-centering structures and saving lives. Thank you.